Hey, welcome to my channel LeetCode. So in this video, we will walk through this LeetCode problem 234 palindrome linked list. So what's a palindrome? Is basically the first number is equal to the second, the last number. Sorry, let me try again. So the first number the same as the last number. The second number is equal to the second from the last number. So it's like a mirror. You look at the mirror, it looks exactly the same, right? This guy looks to this guy, and this guy looks equals to that guy. So this is a palindrome. And we will look at the palindrome on a linked list. So this is where the challenge comes from. It's a linked list. So it's only go from one direction. And we don't know the length of the linked list ahead of the time. And in this case, this is not a palindrome because the first element is not the same as the last element. So that's why it's not a mirror in between, right? So that's why it's not a palindrome. Yeah, so whenever I was asked to see whether it is something a palindrome, I put a mirror in the middle to see if I can mirror everything from the left on the right. So this question was very popular. It's kind of popular. It's asked by this name, and it has almost 6,000 likes. We're gonna solve this problem with two approaches, and I'm gonna start with the most intuitive approach, as you can see right here. So first, we have a term list that is collecting all the possible numbers on the linked list, converted on an array. So in this while loop, basically we're collecting all the number from the linked list to the term list. Okay, so basically while there's something in the head, and then we append the value of on the head to the term list, and then the head will move on to the next one. So the head starting from here, and then collect the value to term list, and then move to the next one. That will be the new head, and then collect the value, and then move on until upon where the head will be none. So that means we will finish the entire list. And then we will have the two pointer to check whether something is a palindrome with the left pointer and the right pointer. So while the left is less than the right, and we're checking the first one is equal to the last one, the second one is equal to the second from the last one, etc. So we just have this if statement here. When something is not equal, the left element is not the same, it's not mirror as a right element, we will terminate the whole thing and return a false. Otherwise, we keep doing it. And if everything is the same, and return the true. And this solution is okay solution. As you can see, it's not too bad, right? Both in terms of the memory, also in terms of speed. And for time complexity, this is going to be big O of n, because we do it one time in here, it's big O of n, and also do it another time in here, it's big O of n as well. So it's big over 2n, the constants drop, so it's big over n. And for space complexity, we need a term list to collect the numbers, so it's big over n as well. So this is not a terrible solution, and also very intuitive. But the challenge with this problem is that there is one follow-up question, and it's asking us, can we do it in BON, which is what we did, and also a big O of 1 space. Okay, so it does not want us to use another external list to collect all the numbers. So it requires us to do everything in place. And this is how I'm going to solve it in the second approach. So this is the approach for using. So this is the approach by using the just big O of 1 time space. So we need to use a two-pointer method. One is the fast pointer, another one is the slow pointer. And so the fast pointer will jump 2 steps each time. Then the slow pointer will jump 1 step each time. So by the time when the fast pointer jump to the end, the slow pointer just right at the middle. So let me show you what I mean by that. So the slow pointer will have a head start. right? So the fast pointer have a head start. This is fast pointer, right? So I will start as the second position, which is 2 in here. Let's look at this linked list right here. So 1 links to 2, 2 links to 3, etc., all the way to 1 again at the end. So the fast pointer, you start at the second position and then jump 2 steps, right? So from 2 jumps to 4, 4 jumps to 3, 3 jumps to 1, which is the end, okay? And the slow pointer will jump when the fast pointer has the room to jump, right? So the fast pointer again jumps 1, 2, 3, 3 steps, and the slow pointer will jump 1, 2, and 3. So the pointer will end up at 4 and that position when the fast pointer is at the end, okay? And then we have a temporary head that will be just right. It will be the next of the slow pointer. So the temporary head will start from here. Okay, and then we can start to reverse the linked list. So the original linked list looks like this. So 4 links to 3, 3 links to 2, and 2 links to 1, and then we will reverse that. So by having the 4, the second 4 links to the pi of 4 like this. The 3 links to 4, 2 links to 3, and 1 links to 2. So after we reverse it, looks like this. So we have the original head that is at position 1. Also, we have the temp head that is in the last position after we reverse the linked list. And then we can compare, right? So we compare this guy with this guy and this guy, the 2 in here compare with this guy over here, the 3 in here compare with this one, until we hit in the middle to see if all the numbers in between are the same or not. If one of them is not, one pair is not the same, and then it will just return the false and then cut off the execution. So let's take a look at how we can implement it in Python code. And first, we need to cover a edge case where if there is only one node and it's automatic palindrome, so it's return a 2. Okay, and then we assign the fast pointer will be at position number 2, so it's head dot next, and the slow pointer point to the head itself at the beginning. And this is to test the case where there are 2 nodes, right? If there are only 2 nodes, that means head dot next, which is the fast head dot next, is equal to none, means there is only 2 nodes available. If the slow head dot value equals to the fast head dot value, if there are 2 nodes, if their value are the same, it will return a 2. Otherwise, it will return a false. So this is another case. So this is a case where there's only 1 node, and this tests the case where there are 2 nodes. Although we have to do these 2 corner case clear out, and then we can implement the algorithm that we just talked about. And so this is doing the traversing. So as I mentioned, the fast head jumps 2 steps for each time, and the slow head will jump 1 step. And then we have the counter. The count exactly how many steps that will be jumping. So because we're jumping 2 steps each time, so we have the counter increased by 2 each time. And then now we find the temp head, which is exactly that. So it will be, because this is the point where the slow pointer will end up with, and then the temp head will be the slow pointer, the next of the slow pointer, which is this guy over here. And then this is where we can reverse the remaining linked list. So we have the original next node. We save that by using the temp head.next. We save that node, and then now this is where we do the reversing, right? So The next one will equal to the previous now, and then we move forward. So the previous will be equal to the old temp head, and then the new temp head will be the next one. So this is where we can move forward. Also save the prior node. So after we keep doing that, and this is gonna reverse to this order, looks like this. So in the middle here, this is actually a double linked list, just one double links right here. So because 4, the next is 4 itself, and 4 is the next is 4 as well. After we reversing it, so and then we assign, because at the end the temp head will be equal to none, because it will be exactly right here, and we need to find this point. So and luckily we saved it by using this the previous variable. So we put it back into the temp head, and this is why we need a counter while the counter is greater than 0, and we check. So the head is right here, temp head is right here, and then we check and then move toward the middle. And then we check the value if that's the same. If it's not the same, it just automatically return false. And then we move the head, also the temp head, and then the counter will decrease by 1 each time until it's equal to 0. And if everything clears out, everything is like a mirror, and return a true. So let's run that. Looks pretty efficient, hey? And for time complexity is exactly the same as before, so it's big O n. For space complexity now, we're doing everything in place. It's gonna be big O1, and that meets the requirement. And yeah, so that's so much for this solution. I hope you like it. If you do, please hit the like button and consider subscribing to the channel. That will be a huge encouragement to me to make future videos like this. And thank you so much for watching, and I will see you in the next video.